Okay, hello everyone. Let us continue the second part of today's course. Okay, please turn to the handouts. Okay, we have just explained what is the decomposability. So next we are going to explain what is Whittle index. Okay, definition 2. If an arm is indexable, its Whittle index W of omega of the state omega is the infimum. Okay, we will explain what is the meaning of infimum later. Subsidy M such that it is optimal to make the arm passive at omega. Equivalently, Whittle index W of omega is the infimum subsidy M that makes the passive and active actions equally rewarding. Okay, W of omega is equal to the inf M of this set. Okay, the set contains OM such that UM star of omega is equal to 0. And this is equal to the inf M of the set of M, okay, such that V beta M of omega and U is equal to 0 is equal to V beta M of omega and U is equal to 1. Okay. So next problem. Okay, what is infimum? Okay, answer. In mathematics, the infimum, abbreviated inf, plural infimum, of a subset S of a partially ordered set P is a greatest element in P that is less than or equal to all elements of S, if such an element exists. Consequently, the term greatest lower power or lower bound, abbreviated as GLB, is also commonly used. So next we are going to explain what is the partially ordered set and the greatest element. Okay, problem 11. What is partially ordered set? Answer. In mathematics, especially order theory, a partially ordered set, also pose set, formalizes and generalizes the intuitive concept of an ordering, sequencing, or arrangement of the elements of a set. Okay, then problem 12. What is greatest element? Answer. In mathematics, especially in order theory, the greatest element of a subset S of a partially ordered set pose set is an element of S that is greater than every other element of S. Okay, let us go back to the slides. Okay, we have used much time to explain what is the meaning of the indexability. Okay, so in Liu and Zhao 2010 and Liu et al. 2011, the indexability of a special classes of RMAB has been established. And in Wang and Chen 2012, Wang and Chen, this paper, which is published in IEEE Transactions on Signal Processing in 2012. And Wang et al. 2014, Okay, 1 et al. Okay, this paper. Oh, this is a paper published in IEEE Transactions on Vehicular Technology in 2014. The myopic strategy was shown to be optimal for a family of regular reward functions that satisfy axioms of symmetry, monotonicity, and decomposability. Okay, what are the axioms of symmetry, monotonicity, and decomposability? Okay, please see the handout. Okay, what are axioms of symmetry, monotonicity, and decomposability? Answer. Let A be a set contains 1 to k, okay, positive numbers 1 to k, and omega A is defined as a set contains all omega I, where I is in A. Okay, so this set is equal to omega 1 to omega k. Okay, axiom of symmetry. A function f of omega A, okay, from 0, 1 to the power of k to r. Okay, what does this notation mean? Okay, this notation means that, okay, f of omega A is the number of the function, and 0, 1 to the power of k is the closed interval 0 to 1, and make the Cartesian product with itself k times. So this is the domain of function f, and R is the set of all real numbers, which is the range of the function f. It's symmetrical if for all ij are in A, it holds that f of omega 1 to omega I to omega j to omega k is equal to f of omega 1 to omega j to omega I to omega k. So that is, if you exchange the order of any two variables, omega I and omega j, among all variables, the value of the function will remain the same. So next is the axiom of monotonicity. A function f of omega A from the closed interval 0, 1 to the power of k to r is monotonically increasing if it is monotonically increasing in each variable omega I, that is, for all I is in A. So if we write this statement into a math equation, okay, it is very clear. Omega I prime is greater than omega I implies that f of omega 1 to omega I prime to omega k is greater than f of omega 1 to omega I to omega k. Okay, next the axiom of decomposability. This axiom says a function f of omega A from the closed interval from 0 to 1 to the power of k to r is decomposable if for all I belongs to A, it holds that f of omega 1 to omega I to omega k is equal to omega I times f of omega 1 to 1 to omega k plus 1 minus omega I times f of omega 1 to 0 to omega k. So it means that we can decompose the original function into the sum of two functions. The first function is f of omega 1 to omega k and times omega I, and plus the second function f of omega 1 to 0 to omega k and times the 1 minus omega I. Okay, please go back to the slides. Okay, so next page, in Cohen's previous work, optimality conditions of a myopic policy have been derived under arm activation constraints. Please see Cohen et al. 2014. Okay, this is Cohen et al. In 2014. Okay, it is a conference paper titled Restless Multi-Armed Bandits Under Time-Varying Activation Constraints for Dynamic Spectrum Access. Okay, in 48th Asilomar Conference on Signals, Systems and Computers in 2014. Okay, although optimal solutions have been obtained for some special cases of RMAB models as detailed, solving RMAB problems directly is intractable in general. Okay, please see Papadimitriou and Tsitsiklis in 1999. Okay, this paper, which is published in Mathematics of Operations Research in 1999. Okay, thus, instead of looking for optimal strategies, it is often decided to develop asymptotically optimal strategies with time. Specifically, a widely used performance measure of an algorithm is the regret. Okay, what is the meaning of the regret? Okay, let us see the handout. Oh, sorry, I didn't include the definition of regret here. So let us look up in the dictionary regret. Okay, regret, a verb. It means to mourn the loss or death of, or to miss very much, or to be very sorry for. For example, regret his mistakes. Okay. And for the noun, it is the sorrow aroused by circumstances beyond one's control or power to repair. An expression of distressing emotion such as sorrow. Regrets, plural, a note politely declining an invitation. Okay, so let's go back to the slides. Okay. Defined as the reward loss with respect to a player with side information on the model. Okay, what is the side information? Let us look at the handout. Okay, what is side information? Answer: supervised, semi-supervised, and unsupervised learning estimate a function given input-output samples. Generalization of the learned function to unseen data can be improved by incorporating side information into learning. Side information are data that are neither from the input space nor from the output space of the function, but include useful information for learning it. Okay, then what is the supervised learning? Okay, answer. Supervised learning, SL, is the machine learning task of learning a function that maps an input to an output based on example input-output pairs. Okay, for example, I want to teach a computer to know which is the photo of dogs and which are photos for cats. And I give the computer many photos, and for each photo I have a tag on it. For example, for a photo of a dog, I have a tag on it named DOG, dog. And for the photo for a cat, I also tag it CAT as a cat. So my computer can use this data to learn that is the example input-output pairs. Okay, to distinguish the photos from dog to cats. Okay, then what is semi-supervised learning? Answer. Semi-supervised learning is an approach to machine learning that combines a small amount of labeled data with a large amount of unlabeled data during training. Give the example of learning the photo of dog and cat. Okay, for example, I now want to use the semi-supervised learning to train my computer to distinguish the photo of dogs from cats. So if using the semi-supervised learning, okay, for example, if I have 30,000 photos, okay, then just a small amount of the photos has a label data. For example, 3,000, okay, has a label, a dog label or a cat label. But with a large amount of unlabeled data during training. That is, for the remaining 27,000 photos, I do not put a label on the photo. Okay, so next, what is unsupervised learning? Okay, unsupervised learning is a type of algorithm that learns patterns from untagged data. Okay, what does this mean? Okay, for example, again, if I want to make my computer be able to distinguish the photos from dogs to cats, okay, then I give the computer 30,000 photos, but I do not put any tag or label on this photo. So I let the computer to learn it by itself. Okay, it is the unsupervised learning. Okay, let us back to the slides. Okay, so we cite information on the model. Okay, an algorithm that achieves a sublinear scaling rate of the regret. Okay, what is the sublinear scaling rate? Okay, it means that the scaling rate is below the linear scaling. Okay, for example, let me draw a picture for you. Okay, for example, Okay, it is the x-axis and it is the y-axis. Okay, so what is the linear scale? Okay, it is the origin. Okay, it's the straight line. Okay, x and y, between x and y, the relationship is a straight line, so it is linear. Okay, if the relationship curve is below this straight line, linear line, for example, like this. Okay, like this. So this is called a sublinear scaling rate. Okay. Of the regret with time is thus asymptotically optimal in terms of approaching the performance of the player with the side information as time increases. The challenge is to design an algorithm that achieves the best sublinear scaling of the regret with time by learning the side information effectively. In R et al. In 2002b, okay, let us see. R and O at 2002b, okay, it is a paper named the Non-Stochastic Multi-Armed Bandit Problem, published in SIAM Journal on Computing. Okay. Regret was defined as the reward loss of an algorithm with respect to a player that knows the expected reward of all arms and always plays the arm with the highest expected reward. Since this strategy is known to be optimal in the classic MAB, that is, multi-armed bandit, under IID. Okay, what is IID? It is independent and identically distributed arrested Markovian rewards up to an additional constant term. Okay, please see Anantharan et al. In 1987. Okay, this paper titled Asymptotically Efficient Allocation Rules for the Multi-Armed Bandit Problem with Multiple Players, Part 2, Markovian Rewards, okay, which is published in IEEE Transactions on Automatic Control. Okay, it is commonly used in RMAB with unknown dynamic settings that allows measuring the algorithm performance in a tractable manner. Okay, this approach was used later in Tekin and Liu in 2012. Okay, Tekin and Liu in 2012. Okay, this paper, Online Learning of Rested and Restless Bandits, okay, which is published in IEEE Transactions on Information Theory. Okay. Okay, and then Liu et al. In 2013. Okay, Liu et al. Liu et al. In 2013. The title of the paper is Learning in a Changing World, Restless Multi-Armed Bandit with Unknown Dynamics, which is published in IEEE Transactions on Information Theory. Okay. Okay, and the third paper is Gaffney and Cohen in 2018 B and A. Okay, let us see Gaffney and Cohen in 2018 B. The title of the paper is Learning in Restless Multi-Armed Bandits Using Adaptive Arm Sequencing Rules. In proceedings, okay, it is 25 minutes. Let us take a break.